In this video, I'll show you how to solve quadratic equations by factoring when a equals 1. In the follow-up video, you'll look at the second case where a equals 2. So, as you can see here, we have already set up the form of the equation we're going to be looking for. We're going to want to get it set up so that we have x squared plus bx plus c is equal to 0, or x squared plus blank x plus blank is equal to 0. In doing so, I'm hoping you'll recognize where this comes from. This is the result of FOILing. Many of you know as multiplying the first, the outer, the inner, and the last. So to get x squared, it will always be x times x. Our challenge is going to be determining what were the two values here that were distributed. So let's take a look at an example and see what happens. Here we have x squared plus 7x plus 12 equals 0. We'll start by setting up our two parentheses, equal to 0. To get x squared, again, it must be x and x. So now, that was our first term. When you look at 12, your last term comes from multiplying the numbers in these two positions here. So to get a 12 from multiplication, we must have had either 1 times 12, 2 times 6, or 3 times 4. This inside term, 7x, comes from the outer and the inner term, multiplying this x times this value and this x times this value. So that's our outer and our inner. Since that's the result of those two, we're going to have to find out what multiplies to make 7 that adds to make 12. And here's our list of choices. So clearly we can see 3 and 4 would satisfy that condition. So we will put plus 3 plus 4 equals 0. Now you can see we have it set up so that we have one quantity, which I'm going to call A, times a second quantity, B, equal to 0. If we can get it to be multiplied to equal 0, either the first term, A equals 0, or the second term, B equals 0. So for this case, we would say that either x plus 3 equals 0, that's in our parentheses as our first term, or x plus 4 equals 0, in our parentheses as our second term. So we can see x is either negative 3 or x equals negative 4 will satisfy this quadratic equation. And we can check that by substituting back in, and it will work. Our second example is slightly different, but we're going to have the same approach. Right away, we can set up our two parentheses equal to 0 to get our first term, x squared. We know it's going to be x and x. And now we're always going to look at our two terms here, our b term and our c term. And we're going to find out what adds to the first multiplies to the second. Just remember AM. It's great to get up in the morning, the AM, and do math. So I'm just going to take that multiply number, that 3, and list those out. This is kind of nice. It's just 1 and 3. There's only one possibility. So I already know a 1 and 3 will be going there. But we have a slight twist here. They have to multiply to make positive 3, but add to make a negative 4. So since it won't be positive 1 and positive 3, it must be negative 1 and negative 3, and that will give us our negative 4. So we'll write x minus 1, x minus 3. Again, set each group equal to 0. So either x equals positive 1 or x equals positive 3 will satisfy our condition. All right, let's apply this to our next example. Again, we can set everything up. Our two parentheses, multiply to equal 0. And we know we're going to look to add to 5, multiply to make negative 4. We know we have x and x. That's negative 14. Let's take our negative 14 and list out the possibilities. It can either be 1 and 14 or 2 and 7. And since we're multiplying to make a negative, one of these signs must also be a negative. So when we say add to positive 5, we're going to have to use one of these as a negative number. So clearly 1 and 14, there's no way to add or subtract to make a 5, but the 2 and the 7 there is. So if I need a positive 5, if I have negative 2 and positive 7, they'll combine to make a positive 5 and multiply to make a negative 14. So I can write minus 2 plus 7. Again, set each group equal to 0. X minus 2 is 0, or x plus 7 is 0, meaning x will equal 2, or x equals negative 7, will satisfy our equation. Our next example throws some people off because they feel like something is missing. But let's go through it the same exact way. We're going to have x and x multiplying to be x squared. And we're going to be looking for what adds to -1 and multiplies to -6. So what people miss is sometimes they don't realize we can put a 1 there to hold the spot, and that makes them feel a little bit better. Again, I'm going to write the -6 over here and write down the possible factors, either 1 and 6 or 2 and 3. And since it's negative, one of these signs has to be negative, so really we can say they're going to subtract to be -1. So 1 and 6 won't work, 2 and 3 will. To be a -1, I would need a +2 and a -3. So we'll go back here and put +2 minus 3. So either x plus 2 equals 0 or x minus 3 equals 0. So we have x equals -2 or x equals +3. Both will satisfy. And again, some people wonder, hey, is it okay if I wrote x minus 3 times x plus 2 equals 0? The answer is yes. The order doesn't matter when you multiply. What matters is that we're keeping the negative sign with the 3 or the subtraction sign and the positive sign with 2. So that will also work. Example 5, we got a slight problem. You'll notice that it's not in the proper form. We don't have it in the form x squared plus blank x plus blank equals 0. So we need to set this thing equal to 0. So we'll move the 20 and the -8x to the other side by subtracting 20 and adding 8x. That simply leaves us with x squared. I'll change the order. You can put the +8x first as long as we keep that sign. Minus 20 equals 0. From here we have the same thing. We can set up our parentheses equal to 0. We can write our little AM strategy, meaning we're looking at what multiplies to -20. That will add to 8. We know we're going to have x and x. So our options are 1 and 20, 2 and 10, 3 doesn't work, 4 and 5. And we're seeing what's going to combine to make a +8 with one of these negatives. 1 and 20 won't work. 2 and 10 will combine to make +8 if we have a -2 and a +10. So we can say -2 plus 10. So now I have x minus 2 equals 0 or x plus 10 equals 0. So x can equal +2 or x equals -10 will satisfy our equation. In our next example, it really doesn't look right. However, this can be the result of application problems many times. So what we're going to need to do is simplify this thing. So we'll start by expanding, in other words, distributing our two terms here, the x and the 2. That's our foiling. So we're going to have x squared plus 4x plus 2x plus 8. On the right-hand side, there's really nothing for us to do. You'll notice that we have like terms on this side we can combine, equaling 2x squared minus x. Now, some people feel an instinct to move everything to the left-hand side. However, since 2x squared is the larger x squared term, I want to move things to the right-hand side. So we'll be subtracting x squared from both sides. I'll be subtracting 6x from both sides, and I'll be subtracting 8 from both sides. That will leave me with x squared minus 7x minus 8. Left-hand side, I'll be left with 0. Some people are uncomfortable with 0 on the left-hand side, so you can say it equals 0 on the right-hand side. It's the same thing. We can just go ahead and erase that if we don't like it. If you're comfortable, go ahead and leave it. Again, we can set up our two parentheses. We know it will be x and x. And again, we have adds to -7, multiplies to -8. I'll write that over here in this spot now, -8. So it's either 1 and 8 or 2 and 4. One of them must be negative. So we would have positive 1 minus 8 equaling -7. So we can say plus 1 minus 8. So either x plus 1 is 0 or x minus 8 is 0. So x equals -1 and x equals +8 satisfies our conditions. I have one more example for us to look at. In this example, we'll notice that there seems to be a missing c term, or c is equal to 0. In a case like this, we can write x squared minus 5x plus 0 equals 0. If you do this, what you're going to be doing is, again, starting the same way, x times x is x squared, but you're looking for factors of 0 that add to negative 5. One of them is going to have to be 0. And if it's going to add to negative 5, you can just write minus 5. So we can put plus 0. But x plus 0 really is just x. And then we have times x minus 5 equals 0. Again, we can set each term equal to 0. So this is where our first term is x. Our second term is x minus 5. So our two answers are x equals 5 or x equals 0. Many of you may recognize a different way to do this by the fact that this could be the result of distributive property, that an x was distributed to both terms. So we can find that greatest common factor, which is x, factor that out, and that would leave us with x minus 5 equals 0. Again, set each term equal to 0, x equals 0, x minus 5 equals 0, so we're left with the same answer. In my next video, we'll look at the case where a is not equal to 1, and we'll look at two different methods of solving that, so look out for that if you need it.